Always true.
Always true.
Oh well, we didn't have anybody call in with trivia answer.
Sad day.
Do you guys think you know the answer?
I always thought it was like the whip hitting itself, but
I used to think that too, kind of like
Right,
like
that it
the-
just like snapped
it's
back.
like that,
and-
yeah,
right,
yeah,
yeah.
and just like hit itself when it slapped back, but
Mm-hmm.
it's not. All right, well, Lily, what's the answer?
Well, the trivia question, once again, was what causes the crack of a bullwhip? And that was a tiny sonic boom. And that happens because a shock wave is created when the tip of the whip breaks the sound barrier. And so it turns out that the cracking noise is actually created by a loop traveling along the whip, and it collects, or it picks up speed, I guess. And when it reaches the speed of sound, it creates a sonic boom. So, yeah.
That's
Pretty interesting. Yeah.
Do you want to explain
Yeah.
that more, or who's explaining that more? Are you explaining that more?
We're both kind of sharing.
I
Yeah,
want to
I mean,
hear
I-
more.
I can talk a little bit about kind of what this would look like and how it's represented and how we
That would be
think about it. Then you could probably give a little bit more detail.
I'll be more specific with the whip itself.
Yeah, so I'll do my best here to explain this because I just kind of learned this stuff today. But if you go on my image here, we can think about, and this is often compared to how water forms these waves. So if you look in the top left here, we have a pebble being thrown into a pond. Sure. Most people have done this before, and it forms these concentric circles. It just forms these waves going outwards, little waves. If you had a slow-moving boat, it's kind of doing the same thing because it's displacing the water and forming these waves. But it's really, if you notice here, it's forming a wave in front of and behind. Like the boat is actually going through these concentric waves if you have a slow-moving boat. But as a boat begins to move faster, in a sense, the boat is starting to travel kind of through these waves because the boat is traveling faster than the waves can propagate or move the water. So if you move even faster, you get basically more of this, what you're familiar with, a wake, where, again, the boat is moving faster than the water can form these waves. So the waves or the wake is formed behind the boat. And this is kind of the same thing that happens when you are flying in an airplane. You basically are displacing the air, and that creates some sort of sound. But when a plane goes faster than the air can propagate the sound, basically that's how the sonic boom is created.
Yeah.
A little bit more information on that.
Sure. So I think, yeah, I mean, the way Nate said it, I think was pretty perfect. But if you can imagine in our whip scenario, so I guess it used to be thought that it was the tip of the whip moving so quickly that had done this, but actually it's the loop of the whip. And really it's just that loop is moving faster than the speed of sound. So those waves are kind of crashing behind the fast-moving loop in the whip.
So interesting. Well,
So interesting.
sadly, we have to say goodbye. So we'll have to catch you again next week, continuing our on sound. We'll see you next week. Thank you again. Tuesday, Wednesday.